Swayam Prabha. Digital India. Educated India.
Dear students, I again welcome you to this lecture on mineralogy. Particularly, we are studying now crystallography. So, we are in the second part of concept of symmetry in crystals. So, you remember in the last class, we have given you this fundamental symmetry operation, that is axis of rotation, reflection and inversion, and I have shown you the basic varieties of rotation, that is one-fold axis of rotation, two-fold axis of rotation, three-fold axis of rotation, four-fold axis of rotation and six-fold axis of rotation here. So, today what we will try to do here is that we will first try to show you some combinations of symmetry, and I will restrict to that kind of combinations where two-dimensional symmetry operations will be there. And what I will try to do is that I will try to combine axis of rotation with parallel mirror planes, and this I am calling as type 1 combination. So, what I am doing here is that I will show you is that we will start with a two-fold axis of rotation, and that is of this orientation here. So, this is vertical, the projection of a vertical axis on this two-dimensional plane of drawing is a point, and I am showing that this is a dyad axis here. So, you now know that the dyad is one where the repeat angle will be, say for example, 180 degree. And let us consider that we have a parallel mirror plane. If you have a vertical axis, then if you have a parallel mirror plane, so immediately you also need to know that this parallel mirror plane will be also of vertical orientation. So, let us consider this bold black line is the orientation of this vertical mirror plane here. So, what I will do here is immediately you can understand that there are two operations will be going on simultaneously. What is that? The rotation with respect to the axis of rotation with respect to dyad, and also you have simultaneous reflection has also to be considered with respect to this reflection or mirror plane, or which is the symbol is given as M. So, which is a symbol of mirror, and let us consider that this is the first position of the motif here. I told you that we are using a nomenclature here that is open circle, that is a motif which is lying at a height h above the plane of drawing. So, what will happen is that with respect to this dyad, the repeat angle is 180 degree. So, this will be rotate 180 degree and will come here, and what will happen? This will be again repeated rotated 180 degree with respect to the vertical axis, and this will coincide with this position, that is your original position here. Now, if you have a mirror plane along this orientation, what will do? So, there will be reflection of this motif with respect to the mirror plane. So, what will it generate? It will generate additional motif here, that is of this orientation, and because the mirror plane, this is one which is lying at a height h above the plane of drawing. So, it will be repeated as the same motif here at the same height h above the plane of drawing. Similarly, with respect to this motif here, the reflection with respect to this mirror will produce another motif here. So, that is why I have written with this arrow here what the reflection is doing with respect to the motif 1 here and also this motif here. Okay. So, what happened now? So, we now have come to this position here. The position here is that you now have this mirror plane, this is the starting mirror plane that we have started with. Now, the question is that if you have a motif here and you have a motif here, and if you have a motif here and if you have a motif here, immediately know there should be a position of another mirror plane here. So, that the reflection of this motif here with respect to this mirror will generate this motif here. So, this two and this two here can also be related to each other by reflection due to the presence of a mirror plane of this orientation. So, that is why in this diagram I have drawn this second mirror of this orientation of east to west orientation here, and this is shown by a symbol, that is bold symbol here. So, now what you have here, you have a two-fold axisymmetry, that is vertical, you have a starting parallel mirror plane here. So, after this operation you have generated another mirror here. So, this second mirror, importantly, the angle between these two mirror is 90 degree. Because the angle is 90 degree, what is happening, these two mirrors are not equivalent. Because why they are not equivalent? Because the mandate of this diode is 180 degree. That is why the rotation of this mirror does not coincide with this. So, it comes to this position here. So, that is why these two mirrors are non-equivalent. That is why what happens here is that we give this symbol here. So, this particular one here is 2 mm. So, when we write 2 mm, you must remember several things here. I with respect to this diagram, I am advising or I am requesting my students to read this symbol very carefully here. The first two is your vertical two-fold axial rotation, and the second M, that is a vertical mirror plane, that is 1 in number, and the second M is the first M, and then the second M. This is also a mirror plane, also a vertical orientation. They are, that is also 1 in number, and the angle between two M's is 90 degree. Okay. So, we have learnt how one two-fold axial rotation and a one vertical mirror plane gives rise to another mirror plane. So, you generate a type of operation which is called 2 mm. We call this as a point group of symmetry and also called a crystal class here. Let us move forward here. Now, we start with a three-fold axis of rotation that I have written here. So, if you have a three-fold axis of rotation, I have to show a triad symbol here, and this is a vertical orientation, and let us consider that you have this particular position of a vertical mirror plane here. This is straight, this is straight, and let us consider that what happened, that you have a starting motif that is shown by a red open circle here, and we know that simple rotation will generate a motif here by 120 degree rotation, another 120 degree rotation, this motif will come here, and another 120 degree rotation will come here. So, this we have already learned in case of triad operation here. Now, we have a one mirror plane here. So, what will happen with respect to this mirror plane? With respect to this mirror plane, this will be reflected and this will produce another motif here, and this is also an open circle here, but I have shown the different colors just to show that this is produced due to reflection of this particular motif here, and this is also at a height h above the plane of drawing. And you can also with respect to this, you can generate this motif here through reflection with respect to this, and also this one on this also, if through reflection of this particular motif, it generates another motif here. So, what you have now is that you have now total of how many motifs? 6 motifs here, and each pair, now I have shown this, the presence of a reflection plane passes between these two motifs. You can also think of a reflection plane will pass between this, which will be this orientation, this will be this orientation here, and also there will be another reflection plane will pass through between these two motifs. So, this in this diagram I have shown this particular 3 mirror planes here, one of this orientation, one of this orientation, and one of this orientation here. Now, see this, what has happened. So, we started with a three-fold axis of rotation and we have a vertical mirror plane to start with, and after this operation we have seen that we have generated 2 additional mirror planes here. So, m plus m. So, how many total mirror planes here? M, m and m. So, there are 3 mirror planes. So, should we write it as 3 m, m, m? No, we should not write this as 3 m, m, m. Each mirror plane can be related to the other by 120 degree rotation, and you see that this can be rotated 120 degree, it comes here, another 120 degree, it comes here. So, all the mirror planes are equivalent. So, that is why if I write after 3, if I write m, that is sufficient enough to understand that in this particular case, that if you have a vertical threefold axial symmetry, if you have if we write M, we know that there is the additional two mirror planes, they are all vertical in orientation and the angle between these two mirror planes will be say 120 degree. So, that is why the symbol will be is 3 M. If you can also go in a different way, is that you have been given three mirror planes M, M and M at an angle of 120 degree to each other, and you can generate a vertical threefold axial symmetry. That way also you can come. So, you do not start with a rotation axis here, you have been given only a mirror plane. So, you can start with immediately we will find out that this will generate a vertical you will have a triad, the intersection of this vertical mirror plane will generate this triad here. Okay. So, just I take, so here we start with a vertical fourfold axis of rotation. So, this is a vertical fourfold axis of rotation here, and what we have here, let us take, we have one mirror plane shown by red bold line, and you know that if this is of one orientation here and if this is a vertical fourfold axis of rotation, immediately you know that 90 degree rotation of this mirror plane will give rise to this mirror plane here. So, these two mirror planes immediately you can start with. If you start with one M, you have the another M, this is equivalent. So, because 90 degree rotation, this is a repeat angle is 90 degree. So, M will be rotated 90 degree and will come here. Now, let us start with this open symbol here, that is red. So, 40 degree 90 degree rotation, it comes here, another 90 degree comes here, 90 degree comes here and 90 degree comes here, and reflection with respect to this vertical mirror plane shown by this red bold line, it generates this I give this symbol here as blue circle here, and there is one blue circle generated here because of deflection here, another here, and with respect to this is generated here. Immediately you know how many total motifs are here. So, 1, 2, 3, 4. So, 4 into 2. So, 8 motifs are generated. Now, immediately you can relate these two motifs and these two motifs by the presence of another mirror plane of this orientation and these two by the presence of another mirror plane of this orientation, which is shown here. So, you see here you have now another set of mirror planes which are now shown with a blue symbol here, and they are that because these are mirror planes, that is why they are bold lines are there. So, what you see that you have started with 4 and you have two mirror planes that are one type, they are related to each other by 90 degree, and they have generated another type of mirror planes which are shown by blue, they are also 2 in number. So, what is important here? So, total mirror planes now how many? So, total mirror planes are 4. So, we can write 4 M, 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 M. So, this is such a big symbol, it is not required. We can just write it as 4 mm. Why it is 4 mm is sufficient enough to describe the total symmetry that has been generated here, because each M that represents they are 2 in number. Say for example, first M is this 2 in number shown by the red. So, the second one is the another set of mirror planes, they are also 2 in number. So, 4 mirror planes have been subdivided into 2 sets. In each set there are 2 in numbers, and in each set the angle between mirror planes is 90 degree, but the angle between mirror planes in the 2 sets is 45 degree. And you can also write it in you can also generate you can go in a different way. You start with 4 mirror planes and you have the mirror planes something like that, you can generate a fourfold or tetrad here. So, we have now learned 3 types of combinations. So, 2 mm, 3 mm and 4 mm as part of one type of combination, which is where axis of rotation is combined with a parallel mirror planes. So, let us come back to the another one here. So, here we have a vertical axis which is a 6-fold axis of rotation. So, we have started with a mirror plane which is shown by the red colored symbol here. So, you see if I have this mirror plane here, so immediately if I, because this is a 6-fold axis of rotation, 60° rotation will produce this mirror plane, and another 60° rotation, this will be rotated here and this will produce another mirror plane, and if you rotate another 60°, this will coincide with the original mirror plane here. So, you in effect there are 3 mirror planes here, and these mirror planes they are equivalent. So, now let us start with this particular red symbol here. This is the starting motif. So, first we have 6-fold axis of rotation. So, open symbol, this red open symbol is generated through rotation. So, there are 6 motifs with red open circle is generated, and then you have a reflection with respect to this is produced here. So, reflection motifs are shown with this blue colored open circles here. Immediately, as we have done for 4 mm situation, immediately you can think of the presence of a mirror plane passing between these two and between these two. So, one mirror plane will be like this. You can also think of another mirror plane will be passing like this. So, this is the one, and you can also think of another set of mirror plane like this passing through this. So, what you have here after these symmetry operations, you have another 3 mirror planes that has been generated here. So, total mirror planes are now 6. These 6 mirror planes can be subdivided into 2 groups. In each group they are 3 in number, as I have shown you here with 3 distinct colors, either red or blue. So, the red set is 3 in number, the blue set is also 3 in number. So, the angle between mirror planes in a particular set will be either 60° or complementary 120°, whereas the angle between mirrors belonging to the 2 different sets, that will be 30°. So, that is very important here. So, that is why we gave a symbol of 6 mm. So, I will encourage my students to read this symbol, and will be immediately will use this kind of diagram to find out that the first symbol tells you about the vertical 6-fold axis symmetry, and the next 2 symbol refers to vertical mirror planes parallel to 6-fold axis symmetry. The first mirror plane, the first M refers to 3 in number, the second one 3 in number. The angle between these 2 mirror plane is 30°, whereas the angle between individual mirror planes in each set is 60° or is complementary 120°. Okay. So, let us try to have another type of operation here, which is type 2 combination operation, where now we will be rotation and inversion will be combined together. In the example beforehand, I have shown you how rotation and mirror planes in parallel position have been combined, and now we are doing another type of operation where rotation and inversion are combined together. So, what we are seeing here? So, let us say that we have a 2-fold axis of rotation. Let us say we have simultaneous rotation and inversion we will be considering. So, the same thing I am repeating once again. This red open circle is a motif lying at a height h above the plane of drawing, and this particular one here, the solid circle in blue, is the h unit below the plane of drawing. So, what happens now? So, first we start with a 2-fold axis of rotation. So, what happens? So, it has been rotated 180° and it has come to this position here, and I have done something here. What is that? That I have not given a full outline of the circle here. I have shown this open red colored circle or circle with an open circle with the red outline, that I have given is dashed outline. Why? Because this is the transient position here. Why transient position? Because rotation will be immediately followed by inversion. So, this is the first cycle will be completed here, rotation plus inversion. Okay. So, what is that? The motif is now lying at a height h above the plane of drawing. If there is an inversion, what will happen? I will join this with this, and this motif will be now reproduced at the opposite direction. If it is at a height h above the plane of drawing, it will now be reproduced here at a height h below the plane of drawing, which I have shown here. So, in the second case, so you see, so from this after this operation, the second operation, this particular motif will be reproduced here due to inversion as this dot here or closed circle here. So, what in nutshell what it means? That means, here you have one motif at a height h above the plane of drawing and one motif at a height h below the plane of drawing. This can only be related to each other if we think of that there is a mirror plane passing through this. What is this mirror plane orientation? This is a horizontal mirror plane of this set. So, horizontal mirror plane, I have shown this as this bold outer periphery of this circle here, which means that you have a horizontal mirror plane here. So, what it has become? So, this rotation plus inversion, that is generally given by this symbol here. We write 2, and over that we have written, we have shown some dash here. So, this is called just bar 2. So, bar 2 is a rotation inversion operation involving two-fold axisymmetry, and this is equivalent to M. So, we have done a roto inversion involving a dyad, but it has not generated any additional symmetry. That symmetry we have already seen with the mirror plane here. Okay. So, let us now start with slightly more complicated part here. And what is that? Sorry, what is that? We have a threefold axis of rotation here, and let us consider that we are doing a rotation and inversion with respect to a threefold axis symmetry. So, what we are doing? So, this is our triad position here. So, this is my starting motif here. So, this is rotated 120 degrees. So, it comes here, and after inversion this open circle comes here as a dot. So, one operation is complete now, one cycle of rotation plus inversion is complete, and I give this newly generated motif, which is a closed circle here, a name as. Now, it is rotated another 120 degree. So, this particular this has come here as dot here or closed circle here. So, after inversion it is reproduced here as, say for example, as an open circle, and I give this name as 2. Second motif is generated. Now, after we have here, so one position is already known, 2 is already known. So, now this open circle is rotated 120 degree and it undergoes an inversion and it is regenerated here as at 3. So, this is a closed circle is generated here. So, after 3, so it is again rotated 120 degree here. So, it comes here, and then after inversion it is reproduced here as an open circle. I give a name as 4. So, after 4 I again allow a 120 degree rotation, and after inversion this open circle is reproduced here and produce a closed circle, and I give a name 5. And now, after this the 5 is we have another 120 degree rotation here, it comes here, and then after that there is an inversion that is going on here. So, it comes here at 6 here. So, the third position also remains as it is. So, no problem here. So, what we have now here, this rotation plus inversion, we call it as bar 3 operation. The symbol is this dash written on top of 3, we call bar 3 operation, that is a rotation plus inversion, that has now produced 6 motifs here. Now, you see carefully the relationship between these motifs. The relationship these motifs here is that these open circles, this in red open circle, they are related to 120 degree rotation. So, very nice threefold axis of rotation, that mandate is maintained, and also same thing happens to this closed dot here, but also we have something additional symmetry is generated here, because this open circle and this closed circle here, they are related to each other by an inversion here. So, there is a center of symmetry here. So, when there is a center of symmetry here, we have to give a new symbol here. I have shown within the triangle, I have shown as a open circle here with a white circle here to show that there is a center of symmetry here. So, bar 3 therefore, can be written as 3 plus I. So, you have a threefold axis symmetry plus you have a center of symmetry here, or inversion center is present here. So, we have studied now bar 2, which is equivalent to an M, and bar 3 is 3 plus I. So, let us study the bar 4 now. So, what do we have in bar 4? So, this fourfold axis is now become a bar 4 axis. What is that? So, you have this starting motif here. So, it is rotated 90 degree, and due to after inversion, this is generated this first motif here, that is a closed circle. I give a name as 1. So, it is rotated 90 degree here. So, the closed circle comes here, and after inversion it is reproduced here as 2, and it is rotated another 90 degree here. So, this open circle comes here, and after inversion this is generated here as a closed circle here. So, it is again rotated, the third motif that is generated is again rotated 90 degree, and after inversion this is reproduced here as an open circle here. So, you have here in bar 4 operation, you have a total of 4 motifs, but this is not as the motif that we see here is not like what we have seen in simple fourfold axial rotation. Why? Because these are not planar motifs here. So, this 2 and 4, these two motifs lie at a plane at a height h above the plane of drawing, whereas 3 and 1 they lie at a height h below the plane of drawing. So, bar 4 operation and fourfold axial rotation, these two are different. But one thing is very interesting here. What is that? This 4 and 2 and this 3 and 2, they can be related to each other by 180 degree rotation. So, bar 4 in essence has now become a twofold axial rotation. That is why this symbol of twofold axis or dyad axis is shown here. But bar 4 is not exactly a dyad. In case of a dyad, only 2 motifs are related and they are planar motifs. In case of bar 4, there are 4 motifs here. So, that is why bar 4 is it acts like a twofold axial symmetry, but it is not exactly twofold axial symmetry. So, this you need to be very careful here. Now, you come to this another operation here, we call it as bar 6 operation here. So, what is how to do it here? So, this is a 6-fold axial rotation axis, this is vertical. So, it is rotated 60 degree and this is inverted. After inversion it comes here and generates a closed circle, we give it a name 1, and then it is rotated 60 degree, it comes here, 1 comes here, and after inversion it is generated here as 2 here. And then 2 is rotated 60 degree, and after inversion it produces this closed circle here, we call it as 3. And this 3 is again rotated 120 degree and it comes here, and after inversion it produces at the same position where 1 was there. Now, it comes here as an open circle here. So, at this position now we have 2 motifs here, one lying at a height h above the plane of drawing, that is 4, and whereas there is another motif which lies at a height h below the plane of drawing, that is motif is 1. So, from 4 we can again the open circle is rotated 60 degree, it comes here, and after inversion it is repeated here as a closed circle, which I call it as 5. So, again here what we are seeing here, we have 2 motifs lying at the same place in this plane of drawing, but they are at 2 different planes. The motif 5 lies at a height h below the plane of drawing, whereas the motif 2 lies at a height h above the plane of drawing. And then 5 is rotated 60 degree, and then after inversion it is reproduced here as motif 6. So, that is your open circle here. So, again you have two motifs lying at a height h above the plane of drawing and at a height h below the plane of drawing. So, you now have three pairs of motifs now 3 6, 2 5 and 1 4. They are at two different planes, and immediately you can tell that there should be a horizontal plane of symmetry, which can relate these two motifs lying at two different planes but at the same height from that horizontal plane of drawing here. So, this operation has generated a horizontal plane of symmetry or horizontal mirror. At the same time, these three pairs, they can also be related to each other by 120 degree operation here. So, they can be rotated 120 degree and coincide with this pair, another 120 degree they can coincide with this pair, and this is 120 degree this coincides. So, immediately bar 6 is now has become a vertical three-fold axisymmetry, and you have a mirror plane somewhere here. So, which we call it as 3 over m. So, here this particular bar 6 is essentially is 3 over m here. So, that is the important thing that is here. So, bar 6 is 3 over m, that is why I have given this symbol of triangle. So, this triangle is essentially is your three-fold axis of symmetry, and this particular one here, this particular one, this is your horizontal mirror plane. So, this is your 3 over m. Okay. So, we have now learned these two types of operation now. So, we have ended here is that type 2 combination operation we have studied here, and now let us try to learn a third types of combination of symmetry elements here or symmetry operation. What is that? This is we call it as combination of all the rotation axes. Now, if we consider that there are three rotation axes are combined, and if the three axes, the foldedness we call it as x, y and z. So, then only those combinations which satisfy this equation, that will only be that combinations will be possible. So, there are three symmetry axes, and I have given it in this table what are the combinations possible and what is the interaxial angles, the angles between the three axes here. So, this is 1, 2, 3, 4, 5, 6. So, I have shown 6 fundamental types of combinations of symmetry axis are possible. The first is 2, 2, 2. The angle between this axis is 90 degree, and in case of 3, 2, 2. So, you have 90 degree angle between 3 and 2 and 3 and 2, and the angle between horizontal two-fold axis. So, this are horizontal two-fold axis, in this case 2, 2, 2. This y and z are in the horizontal plane. In case of 3, 2, 2, these are also in horizontal plane, and the angle between two axes is around 60 degree or 120 degree the complementary. In case of 4, 2, 2, the four-fold axis or tetrad is vertical. In the horizontal plane, you have two-fold axis symmetry. So, the angle between this horizontal two-fold axis is 45 degree. And in case of 6, 2, 2, so you have the vertical axis is hexad, and in the horizontal plane, you have two varieties of two-fold axis. The angle is 30 degree here, and you have some two unique situations here, where you have a four-fold axis symmetry, and this two axes here, three-fold axis symmetry and two-fold axis symmetry, they are not in the horizontal plane here. So, they are not always in the horizontal plane, and these are the angular restrictions that are present here. So, angle between four-fold axis symmetry and three-fold axis symmetry is 54 degree 44 minute, whereas angle between four-fold axis symmetry and two-fold axis symmetry is 45 degree, whereas the angle between three-fold axis of symmetry and two-fold axis symmetry is 35 degree 16 minute. And you have the final combination that is possible is 2, 3, 3, and this is 54 degree 44 minute, this 2 angle 3 and 2 angle 3, this is, and the angle between the three-fold axis symmetry is double of this is 70 degree 32 minute. So, in the drawings that I will show you that this angular orientation as well as their numbers, we will be able to understand very easily. So, let us start with this first operation here. So, this is the rotation, we have the two-fold axis rotation here. So, this is a vertical two-fold axis rotation, and let us consider this line is the trace of a horizontal two-fold axis here. So, you have here this open circle here. So, this is rotated 180 degree, that with respect to vertical two-fold axis, and then it comes here. Now, if this is a horizontal two-fold axis, so what will happen here? This will be rotated 180 degrees. So, it will come to a plane which will be at the plane below the plane of drawing. So, it will be repeated here with respect to this horizontal two-fold axis rotation. It will produce a dot here or closed circle here, and it will form this, and these two can be related to each other by the presence of another two-fold axis of symmetry here. So, what you have here is that you have here three two-fold axis symmetry, one of vertical orientation, one of this horizontal orientation, and this is another horizontal orientation. So, this two-fold axis symmetry in the horizontal plane, they are unrelated to each other, and also the one which is in the vertical plane, they are, this is unrelated the horizontal two-fold axis symmetry. The angle between all the two-fold axis symmetry is 90 degree, and we know this with this symbol here is 2 2 2. Now, let us see what happens if we have a vertical three-fold axis symmetry, and we start with a horizontal two-fold axis which is of this orientation here. So, what you have is that you have an open circle here. So, this is we have already studied. So, we have generated these two additional motifs because of the presence of triad, and if you have a horizontal two-fold axis symmetry. So, the rotation of this will produce a closed circle here same way. So, once you have this, the rotation of this will produce this another 120 degree rotation like this. So, immediately you know that you have the development of another two-fold axis here, another two-fold axis here. So, what you have here, we have started with this two-fold axis of horizontal orientation, you generate another two-fold axis also in the horizontal orientation, and the angle between the two-fold axis symmetry is 120 degree. If I talk about this and this is 120 degree, I talk about this and this 120 degree, and this again 120 degree here. So, with the starting two-fold axis, you have generated another two-fold axis, two two-fold axis, total 3, but as we have seen in case of 3 m, we call it 3 m, the two horizontal two-fold axis, they are equivalent because they are related to each other because of the angle of 120 degree, which is the mandate of repeat angle of the vertical three-fold axis. So, that is why we call this as 3 2, not 3 2 2 2. Okay. So, let us now come to the next one here. This we call it as a vertical four-fold axis of rotation, and let us consider we start with a horizontal two-fold axis symmetry on of this orientation, and because this is 90 degree repeat angle. So, you have automatically there will be another set of two-fold axis here. So, what you have here, this 90 degree rotation with respect to the vertical axis will produce additional 3 motifs of 3 open circles of red color, and because of this operation of this horizontal two-fold axis of this orientation and this orientation here, it produces 4 additional motifs here, which are now closed symbols here. Because this closed symbol here and open symbol, they can also be related to the presence of another two-fold axis of this orientation here, another two-fold axis of this side. So, what happens here? A total of 4 horizontal two-fold axis is present, but they occur in 2 sets. I have shown it through different colors. In each set there is 2 in number, and the angle between the two-fold axis, horizontal two-fold axis is 90 degree, and but the angle between the two-fold axis in the 2 groups, so that is 45 degree. So, that is why we give this symbol here 4 2 2 to distinguish 2 different varieties of horizontal two-fold axis symmetry. Now, we start with a vertical 6-fold axis rotation, and in the horizontal plane you have one set of two-fold axis. So, let us consider this is this. Since the mandate of this vertical two-fold axis is 60 degree, this is rotated 60 degree. So, it comes here, another 60 degree it comes here, another 60 degree it comes here. So, you have the positions of two additional horizontal two-fold axis. So, they are related to each other. So, first you generate this total 6 motifs which are in open circle because of the rotation of the vertical 6-fold axis symmetry, and then the presence of this horizontal two-fold axis symmetry will generate from this particular open circle this particular closed circle here because of this horizontal two-fold axis. So, 180 degree rotation in the opposite direction will generate a motif which is lying at a height h below the planar drawing. In the same way, you can generate this particular, once you generate one, the additional 5 will be generated because of this vertical 6-fold axis rotation here. And immediately you can think that another set of two-fold axis will be of this orientation, another set will be of this orientation, another set of this orientation which will relate this to this 2. So, this I have shown by this particular different symbol here. So, this symbol I have shown it with the blue one here. So, in nutshell, how many total two-fold axis symmetry in the horizontal plane? They are total 6. They occur in 2 sets here, which I have shown in 2 colors here. In each set there are 2 in number, 3 in number, and the angle between the two-fold axis symmetry in each set is 60 degree or is complementary 120 degree, whereas the angle between the two-fold axis symmetry in the 2 separate sets, that will be your 30 degree here. So, it is the symbol that is used here is 622, where the 2 which is in the horizontal plane, they are distinguished because they are not equivalent horizontal two-fold axis. Okay. Now, we come to the 2 remaining one here. So, now we talk about a combination of rotation axis, where we have combined with 4-fold axis rotation, 3-fold axis rotation and 2-fold axis rotation here. So, this is the orientation of this axis is understood with respect to this guide cube here. You see that in this cube there are 6 faces here, and these are the normals which are oriented along this. So, these are the 3 normals. This is a vertical orientation. One normal is this perpendicular to this face, another normal to this, and which will be also perpendicular to the opposite face here, and you can also the frontal face, the normal to this is this axis. All these normals are 4-fold axis rotation. So, there are 3 4-fold axis rotation, one is a vertical orientation and the other 2 are a horizontal orientation. Whereas, you have 3 body diagonals here. So, this red colored line, they refer to 3-fold axis rotation. So, this is one body diagonal here, another body diagonal here, another body diagonal here, another body diagonal here. So, there are 4 body diagonals in this cube. So, the body diagonals are the opposite corners that have been joined with each other. So, there are locations of 3-fold axis of rotation. Whereas, if you have the edges here, so the midpoint of this edge you can join with the midpoint of this edge. So, what you have here? You have these are edge diagonals. So, there are 4 edge diagonals which are of inclined orientation. One edge diagonal I have already shown, another edge diagonal of this orientation. So, essentially there are 4 edge diagonals which are of inclined orientation here, and you can also have another edge diagonal from this point and this point. So, this is one edge diagonal here and another edge diagonal here. So, these 2 edge diagonals are the horizontal orientation. So, what you have here is that in case of 3-fold axis rotation, they are 4 in number, they are all inclined, and there are 6 2-fold axis rotation, they are 2 of them are horizontal, 4 are inclined. So, which I have written here. So, 4 angle 4. So, the angle between the 4-fold axis they are all orthogonal. The 3-fold axis rotation which is shown by this red color. So, angle between 4-fold axis rotation and 3-fold axis rotation is 54 degree 44 minute, whereas the angle between 4-fold axis rotation and the 2-fold axis rotation is 45 degree. And the 2-fold axis rotation, these are green symbols. So, these are edge diagonals, they are 6 in number, 4 inclined and 2 horizontal, and the angle between 2-fold axis rotation and 3-fold axis rotation is 35 degree 16 minute here. And this is the orientation that I have very nice, this is very nicely shown here. This is the edge diagonal, this edge and opposite edge here, and this is the body diagonal here, and this is perpendicular to this face. These are essentially normal. This is four-fold axial rotation here, and this is what we have done here. So, I have shown that how we can do it here. So, this is the orientation of four-fold axial symmetry, that is the center, and this is the vertical one, and this is a one horizontal four-fold axial symmetry. This is another horizontal four-fold axial symmetry, and what is shown here is that the body diagonals which are now inclined, they plot within the circle here, and I will show you that why this is so. At some later stage of the talk, we will show you that inclined axis, they will plot within the circle, whereas horizontal axis, as I have already shown you, they will lie at the periphery of this circle here. So, there are 6 two-fold axes. So, the inclined one are shown by this green symbol, whereas the horizontal one is shown by this red symbol here. So, let us start this. This is your starting motif here. So, four-fold axial rotation. So, I have shown you here, and then you have the three-fold axial rotation will start here. So, this is a three-fold axial rotation. So, 120 degree. So, this has generated two additional motif here. So, everywhere from here you can generate 120 degrees. So, you see here that there are this curved line, this curved line, and this particular straight line has generated 6 quadrant here. So, angle between this line and this line is 120 degree. The angle between this line and this line is 120 degree. So, you can have this particular 120 degree rotation. What will happen to a particular motif is very nicely done here. So, what you have here is that for 4 positions here. So, three-fold axial rotation will generate 2 additional motifs here, which I have shown here. And then you have this 2 horizontal two-fold axial rotation. So, immediately you know that from here the horizontal two-fold axial rotation will produce another motif here at 180 degree position, but in the opposite direction. So, if it is lying at a height h above the plane of drawing, this will be generated at a height h below the plane of drawing, which we shown here as the closed circle here, and this closed circle is shown here. So, once you find one position here, so automatically three-fold axial rotation will generate these 2 positions here at 120 degree to each other. So, everywhere you can have this particular operation here you can have. So, what you have now? You have now here you have say 6 motifs here. So, 24 motifs have been generated. So, you see the symmetry in this particular case is very high, and this the symbol here we call it as 432. So, how the combination of four-fold axial rotation, three-fold axial rotation and two-fold axial rotation, they have generated this particular pattern of motifs here. Now, let us come to the last one here. So, where we are considering the combining two-fold axial rotation with three-fold axial rotation. The two-fold axial rotation, they are 3 in number, three-fold axial rotation is 4 in number. So, what you have here as before, the only difference here, the two-fold axis 3 in number, this one is vertical, that is vertical diad, and this one are the horizontal diads here. And what you have here is that you have the positions of 4 inclined triads here, or which are body diagonals here. So, what you have? The starting motif here. So, you have a rotation here. So, this is 180 degree rotation, this comes here, and what happens here? After this three-fold axial rotation comes into being, what happens? You have this particular generates this particular motif here, and this also have this three-fold axial rotation as generates 2 additional motif here. And since you have a horizontal two-fold axial rotation, so rotation of this motif open circle with respect to the horizontal circle will generate this motif here. And so, the three-fold axial rotation will produce 2 additional motifs here, I showed you here, and here also 2 additional motifs, one here and one here. So, this is in nutshell what you have here is the total 3 into 4. So, that is 12 motifs are generated here. So, you have here this combination of two-fold axial rotation and three-fold axial rotation, they have produced this kind of symmetry of operations or symmetry of their motifs here. So, what we have, so with this we to this particular combinations of rotation axis, that is this type 3 combinations we have studied here. So, up to this stage, if I summarize what we have studied up to this in symmetry operations. So, we have studied the fundamental symmetry operations as one-fold axial rotation, two-fold axial rotation, three-fold axial rotation, four-fold axial rotation and six-fold axial rotation. Then we have studied mirror or deflection and inversion. Then we have studied a combinations of rotation, combinations of symmetry operations. The first type of combination we have studied, where we have combined vertical axis of rotation with vertical mirror planes or parallel mirror planes. Under this, what we have studied 2 mm, 3 mm, 4 mm and 6 mm. And then we have studied another type of combinations here, where rotation is combined with inversion. We call it as roto inversion. So, under this we have studied bar 2, which is equivalent to mirror. We have studied bar 3, which is equivalent to 3 plus I, and we have studied bar 4, which is broadly equivalent to a dyad, and we have studied bar 6, which is equivalent to 3 over m. And then we have studied a type of combination where all the three types of rotation axis can be combined here. So, in this we have studied 2 2 2, 3 2, we have studied 4 2 2, 6 2 2, then we have studied 4 3 2 and 2 3. So, in the next class we will now go forward and we will see the other types of combinations of symmetry elements that are possible here. Thank you.